they have already shared my profile, so I'm just going to skip the first one. This is about few of my Google Scholars and Scopus details. These are the three projects which I have completed. The first was on the forest fire, the second was on identification of tomato disease, and the third one was based on the IoT based technologies. So these are the few books which I have published in past few years, and these are the few latest publications from the Springer. This book is basically related to the sustainable smart cities challenges and the practical considerations. So this has already published, and it is indexed by Scopus, DBLP, and Web of Science. This is another book which is already in publication, and here we just try to explore the possibilities of how the data science and AI technologies are useful for the digital healthcare. So the whole idea was, we know in the healthcare industry, the data science and AI is being used at several ways. So we just try to put our efforts how this data science and AI is still helpful for the digital healthcare, which includes your smart wearables like a smart watch, how we can collect the data from the different you say nodes which are relevant to the patients, and whether the data which is being collected is useful in several aspects or not. So this book is going to publish in the Springer series of signals and communication technology, and this series is also indexed by Scopus, DBLP, and Web of Science. So this is about to publish in next few months. And as far as the today's talk is concerned, I will be just focusing on the three part. In the first part of my presentation, I will just try to discuss few of the background studies, how the various applications have used the benefits of data science and its relevant technologies, and how the data science technologies along with the integration of AI make the products and the services more impactful. And then there was another study which we conducted, and it was related to the disaster management. That is one of the area where the data science and the AI play a crucial role. So we just made this study, and in that particular study, we try to identify and address the challenges during the forest fire detection. And in that particular identification, we use the integration of data science, IoT, and image processing techniques, and we try to explore how these similar technologies could be used for the smart cities. And the outcome of this particular case study was published in a paper with the name of journal Sustainable Cities and Societies, and this journal has an impact factor of 5.2, and this was an SCI Scopus and Web of Science Index journal. So let's begin with the basic background. As far as the first part, which is related to the data science technologies and the smart cities is concerned, we have to look from the social aspects of making our cities smart. As far as the social aspects are concerned, uh, indirectly it is a responsibilities to develop these smart communities which can work toward the advancement of city infrastructure management, and the technologies which can make our home much safer, much cleaner, and the technologies which can contribute in the energy efficient way. So, as far as the energy efficient methods are considered, nowadays we all are aware of the number of buzzwords like green technologies and the green computing, and the smart grids are also very popular. Where in the smart grid also the data is being used to understand the pattern of the uses, and accordingly the either the device is being trained or the customer are being trained. And probably we might have seen in the market as well in India nowadays a lot of electronic devices which are coming in the market, they are also energy efficient. And they that is the reason nowadays, if you look at the different electronic devices, they are also an intelligent device with the integrated AI systems. Like, let's suppose if you go and buy air conditioners. Now most of the companies in their in their smart range, they are coming with the air conditioners which have the AI enabled system, where the AI sensors, AI basically how the AI is applied, the sensors sense the data, and within a closed room they try to identify how the temperature has varying from the higher degree to lower degree, and if it has reached to a certain level, that sensors can just notify to the compressor, so the compressor can just stop for a time being, and then it can again start the cooling, and this is how some energy could be saved. So we all of us might have seen the five-star rating was earlier 2 to 3 years ago. It was there in the market, but now along with this star rating, the AI-enabled devices are available in the market. So we have to see from that aspect how this data science and the AI is useful in the devices, and how it could make the life easier for us in one aspects or other aspects. The another aspects for looking at the social aspects of making the city smart is involving communities. So, as far as involving communities is concerned, whether these technologies can assist the local organizations, government in design and implementation of smart cities in aspects of social and political aspects. As far as you can see, there are a lot of uses of these technologies. Now, the data is being sensed, whether it's related to the traffic, or whether it's related to the pollution, or whether it's related to other aspects of a particular city. Nowadays, in the developed countries, the people might have using, and I have seen and gone through a few research papers which have already been published, where the people are using the smart cameras and they are monitoring the data uh, in smart cities, in context of the people who used to throw the garbage on the roads. So if somebody who's throwing a garbage at the roadside, the camera will be able to catch the pictures, and accordingly if somebody who's throwing from their bike or their car, they can just capture their number plate, and accordingly based on the number they issue online challan. So this is how in that particular case, by involving communities and the local bodies, the government can design and implement a number of ways to make the cities more smarter, more cleaner, and from the cleaning aspects and from the other services aspects. As far as the good governance, smart education, and the other services are concerned, this data science and AI is being used at all levels. And there is another you say an integrated technologies which is required and which is part of it, and that is basically a machine to machine communication. So as far as machine to machine communication is concerned, because of the availability of higher data rate and the existence of 5G, the smart cities are now able to integrate these particular applications, and the acceptability of these application is much wider as compared to the few years ago, because the issue was the data transmission rate. And nowadays, the smart transportation is the another key area where these particular technologies are being used for parking the vehicles. So there are a lot of papers which are available, how the smart parking could evolve, how we can optimize the traffic, what could be the way to find the alternative routes, and how we can reduce the road congestions, and that is based on the available infrastructure. So without changing much the available infrastructures, can we identify the alternative way? Can we just use the smart transportation techniques so that could basically help the community, or the drivers to commute better? So as far as the applicability of this data science technology is concerned, I try to identify the key technologies in aspects of smart cities. So as far as the data science and the business analytics for smart cities is concerned, These are few of the key applications, and one of them is smart transportation, which I have just discussed. So in this particular case, the emphasis is on the better public transport planning to reduce the travel time, and if we can predict the conditions of the jam, and we can identify the alternative routes, that could be a better way. And we can just find few of the studies which are based on the pedestrian behaviors analysis. If you want to walk through a particular source to a destination, how many routes are there and what could be the best route. And indirectly, we all know that the Google Maps are providing few services, but and beyond that, some facilities are also being tried in various studies, where based on the uh, different settings, you can just identify what would be the best way to commute. Apart from that, there could be a transport infrastructure maintenance through the data science and AI based technologies. Because as far as the infrastructure maintenance is concerned, I have shared one example. And few of the developed countries, the traffic police has placed some cameras, and they're just uh, trying to analyze automatically the behavior of the people who are just driving on the roads and throwing the waste materials on the road. So somebody who's throwing the garbage on the road, that person can easily be caught in the camera, whether it is being sent by a two-wheeler or a four-wheeler, and according to the identification on the number plate of a particular vehicle, they can issue the traffic challenge. So this is how the smart transportation is being you say planned, and they are a lot of possibilities with the new technologies which could make the cities much smarter as compared to the current scenario. The another area which is very popular in aspects of data science and business analytics is the disaster management. So as far as the disaster management is concerned, it covers the natural hazards. It manages the information flow in the disasters. It just look at to track the resources to predict the future environment changes or the natural disasters. The road accidents and the road network resilience also come under the smart disaster management as well. So there is a need to prioritize a few of the requirements, and if there are some ways where we can identify some situations, and we can do some efforts to monitor those situations and to analyze those situations. So where the risk which are associated in case of disaster management could be reduced up to some extent. So in the similar regard, we took that study which I have shared in the last PPT. We just conduct a study which is related to the forest fire detection, where we have used integration of IoT and the data science and the image processing tools to capture the images of the various instances and report it to a particular nearest station, so we can control the forest fires at the earliest. And normally the we can handle the natural resources loss. So this is how this is one of the area where we try to address one of the problem as a case study. So I'm just going to share that case study in next few of the coming slides. There is another area which is very popular and where some of you might can look at if it attracts you is smart energy. So as far as the smart energy systems is there, the smart grids are very popular, where the most of supply of the electricity is being integrated with the AI tools, and according to that, the load may be shifted depending upon the demands and the requirement. There's there's few systems which are in place nowadays which can forecast the energy demand. They are the cases where the accidents are being prevented in case of the energy supply. And the load modeling and the smart apartments are is another applications, where in the smart apartment we optimize the apartment electricity uses So as far as the optimizing the apartment electricity uses is there, they are smart switches, they are smart lights. So if let's suppose somebody who's in a common area, who's if somebody is using a common area and somebody walking through a common area, the lights will be on. And if there's nobody in the common area, the light will automatically switch off. So this is how we can optimize the electricity uses. Of course, initially this technology is quite expensive at the initial stage, but if we remember a few years ago, the sensors was quite expensive, but nowadays, we are using sensors at most of places. You go to watch a movie, you will see the sensors in the washrooms. You will see the sensors at the entry point where the door automatically open, automatically close. So nowadays, as the cost of sensors are reduced, it is being used at most of places where it is required. So in this similar way, what I believe is initially this smart optimized electricity applications could be expensive, but slowly and slowly, when it could be more convenient for the user and there would be more demand, so there would be more production as well, and the cost will get reduced. As far as another area where we publish our second book is related to the smart healthcare. So as far as the smart healthcare is concerned, the whole emphasis is on analyzing the disease patterns, and the next could be how the patient can stay and treatment outcome predictions. What about the e-treatments, or what I would say, nowadays the doctors are available on video call. So there is one product which is being developed by the CDEC Mohali, and that is e-Sanjeevani. So as far as that product is concerned, this is being launched by the government of India, where you can take the assistance of doctors using that particular app. So the telemedicine is one of the area which is very popular nowadays. Apart from that, the evolution of the data science and AI technologies makes the medical decision support systems much effective. And the whole idea is these decision support systems are not to replace the role of doctors or the practitioners, but these are to assist the doctors. So if some reports are ready, that reports could be feed into those particular decision support systems, and based on the attributes of those particular reports, the decision support system can recommend based on its past training. So once something is being recommended, this is an assistance for the doctors while analyzing a particular disease or analyzing those reports. So this can do a patient profiling at an earlier stage, and later on, based on the experience and the identification of a disease, the doctors can recommend a particular patient in a better way. This could also help in identifying a risk in a patient at an early stage as well. There are a number of smart health monitoring devices, and that's basically includes from a low level to a high level monitoring. As far as we look at the low level monitoring, if you look at the smart watch, they are able to identify your physical activities in a day, how many steps you walk, what was your pulse rate in a day. Apart from that, there are few devices which support and they can identify your heartbeat. And nowadays, there are smart devices which is in similar form like your smart wearables, where a person can wear a sensor and can monitor your sugar level throughout the day. So that kind of devices are already there. Although there are some challenges while you are using, but these are a few of the techniques and the devices which are still available in the market. And probably what I believe is there would be a lot of innovations with the help of the evolution of data science and AI. And in coming time, the healthcare will also be an area where we will be using a lot of AI based and data science based tools in most of the subdomains of healthcare. There is another area which is also very popular, and the people are doing a lot of research, which is related to the social media for smart cities. As far as the social media is concerned, we all are using it and through the various applications. But here we need, if we look at the uses of the social media, sometimes it is very helpful to get the feedback. Sometimes it is helpful in, you say, prioritizing some urgent information or the situations. And based on this social media, we can identify the patterns of the different scenarios. As far as the election campaign is concerned, nowadays the most of developed countries and even in India, there are number of political parties which have used this social media as a platform, and they can easily identify their current status, what the people think about them, and whether the scenario is positive, negative. So this is one of the platform which is being indirectly used. So I will be just taking care of second part with the help of our case study. So we will touch upon how the disaster management systems uh, are being improved through the key technologies which are available. So this we can skip for a moment. These are the few examples which we are already aware of, where our data is being used by these particular companies, and they have come up with very innovative and good solutions. Like Uber, they do not have a car, but still they are the largest taxi service providers. If we look at the Airbnb, they are using only the data of the customers, and they are the largest accommodation providers, yet they do not have their own homes or the hotels. And if we look at the Kickstarter, this is one of the crowdfunding business which started in 2016. And the best part is they do the crowdfunding, but they do not have their own funds. So this is just a platform where the people are provided a platform. And so here are, if you look at the technologies which is being used is data science and data analytics technologies. If we look at the another two more products which are very popular, one is Rangde, which is the co-founder is Smita Ram and Ram NK. What they are trying to do is they are providing a low-cost loan to the rural entrepreneurs across the India. And the best part is the most of the borrowers have been the women. So this is also very popular where they are using the customer data to do their profiling and to identify their current status and their past status. The Faircent is the another peer-to-peer lending platforms, and this is a kind of virtual marketplace where the borrower and the lenders can interact directly. So this is a kind of platform which comes together the borrower and the lenders. And in that particular case, if you look at their dispersal amount, that was around 9,070 973,000 US dollars in last 2 years. And they are again using the data science and analytics technologies. This is another the popular application which is already in place. So that is called as Nedelize, where the software company in Netherlands, what they are trying to do is they analyze that if they put the servers at an office location, the servers are consuming a lot of energy. So they identified that there are few places in the Dutch area where the most of the homes are cold. So they place their servers in their homes so they can dissipate the heat. So that heat which is being dissipated can be used to warm the homes. So indirectly, these servers can work as a heater, and this company is paying back to the owner of the homes to maintain and providing the electricity to the servers. So the same time the server are connected to the Netherlands cloud. So this is how the data is being stored and energy is being saved, and that energy which is being dissipated from the servers can be used for uh, the individual homes. So indirectly, they are working as a heater. So this is very innovative facilities, and this is how they are using the smart this Nokia, we are using it, and nowadays we have the Google or the other platforms where you can just train. And here in this particular case, as far as this Nokia device is concerned, this Nokia device is basically a battery powered disk where based on your specific knock, you can just switch on and switch off the lights. So this is how this particular startup get very popular. So based on specific knocks, nowadays the voice-based command is also available, and this is another, you say, drones or the UAVs which are being used. So this give us an you say an idea that let's use the UAVs and the IoT devices to just do the analysis during the forest fire incident. So that's how we thought let's begin a study, and that I'm going to share with you in the next coming slides. So this is how the case study on which we worked upon. So we developed an integrated fire detection system using IoT and image processing techniques for the smart cities. So the first question was, what could be the common causes? So the common causes which we identified for the forest fire was due to the environmental issues and due to the human related issues. So we made a study and we identify uh, how much part of area across the globe is basically covered by the forest. So if we look at the maximum part of area in the Russia is covered by the forest, which comes around 45% of the area belongs to Russia is a forest land. And if it comes to India, it is around 30% of the land is covered by the forest. So if you look at the kind of you say if in a particular country if one third area is being covered in the forest, it means we have a lot of resources, and these resources are our natural resources. So there is a need to safeguard those resources, because usually every year due to the forest fire a lot of natural resources get waste. So we try to identify in this particular case, you can see the percentage wise forest area, where in India it is almost 30%, while in case of there are few countries like Venezuela where the forest area is almost 80%. In the Brazil it is more than 50%. So the we just try to identify in the next study that if we look at the incidents, so how many incidents are reported in various years. So we just at that time identified the incidents which are reported in year 2018, and India itself there was more than 10,000 incidents of fire that has been reported between April 1 and May 2. So this is just, if I would say, almost a month where more than 10,000 incidents were reported. So if I will just go to the entire year analysis, there are a lot of you say incidents which took place every year, and because of the incidents of these forest fire incident, there are a lot of forest resources which are basically get waste. So these are the few dots we put according to the number of incidents which were reported. And in this particular case, the maximum number of incidents which were reported were in Uttarakhand, then in MP, and then Odisha. So then this gave us a great motivation that let's identify the reasons and just try to identify the causes. And if we can identify this forest fire detection at an early stage, we can save some resources. The whole idea was, and we all are aware of, we cannot control these incidences of forest fire, but our motivation is if we can report the incidents of forest fire as soon as possible, the concerned authorities and the forest department can take some measures where the kind of loss which occurred due to the forest fire could be reduced up to some extent. as far as the wildfires over the worldwide is concerned, these are the reported incidents of the forest fire globally. So these particular numbers are in millions between 2004 to 2019, and in 2004, globally the number of wildfire incidents which were reported were around 5.09, and similarly we have shown it from 2004 to 19. Now, as far as the analysis is concerned, we try to do the identification of the related works, how different peoples have worked, and what are their identification and what kind of technologies they have used. So we try to identify the papers which were the popular one, and few of them we start collecting from 2008 to 2018. So we identified that as far as these papers are concerned, the people have used the tools and technologies which are popular. One was Zigbee. The different people have used and implemented their systems using MATLAB, or they have used the GSN, WSN based modules. So we just identify the schemes and the tools which are being used in case of the forest fire detection, and accordingly uh, we identify the key systems which are in place. So in that particular case, the key popular technologies which have been used during the forest fire detections are being identified as wireless sensor networks, the sensors. Along with sensors, they are the image processing based tools. Then the few studies have used the satellite based techniques to identify those incidents, and to further doing the analysis, there are a number of studies which have used the neural network and AI based techniques to identify and report the incidents in the correct way. And the people have used in and few of the studies in the drone as well. So this is how this gave us an idea to do a comparative analysis on the techniques which are available. We just listed those techniques and identify the comparison parameters which are used in different studies, and this is how we identify the comparison parameter. Thereafter, we identify how the WSN can be used to sense the data, and how this data can be used as an operational data in the actual scenario. So as far as the implementation of WSN is concerned, we try to build up the scenario in the similar way as it is shown in the figure. So we identified a sensing field, which is an area, and in that case, we deployed few of the nodes, and that these particular nodes are supposed to the cluster head. So in this particular case, we use the cluster head scheme. These are the few of the images which are available. So these were the few modes which we have used, and these modes were carrying different kind of sensors to collect the data. So in order to just set those particular modes, we first check their values in-house inside the lab, and once we checked they are reporting in the right order, then we have applied these particular sensor modes in the outside area. So what we try to do is we just put the sensor modes in the outside area where actually the forest is there, and then we created the scenarios by using the the waste material, and in that particular case we try to observe the various values of the sensors in aspects of temperature, humidity, smoke, and the impact of sunlight. So these values were identified, and we conducted this experiment at various places. So these were the few values which we have observed in 2019. So if you look at the instances, and we try to identify the values of humidity sensors, the smoke sensors, the temperature sensors, and the value from the light sensors in form of lux. As far as the temperature is concerned, the temperature was identified in case of the Celsius, and the smoke were calculated in form of ppm. So over the period of time, this particular data which was reported through the sensor modes, it was transmitted to the ThinkSpeak cloud, and that ThinkSpeak is basically one of the tools which is available in the MATLAB. So this tool was used to draw the graphs, how the humidity is varying over a period of time, how the temperature is varying, how the smoke and the value of the loud light sensors is varying over the period of time when such scenarios are being created. So in that particular case, we try to carry out a comparative analysis in respect to the different data sets which are available. And after doing these studies, we identified that as far as this particular system is concerned, this system was able to uh, the develop this entire system with the help of sensors and the ThinkSpeak cloud. The sensor information for the temperature, humidity, light intensity, and the smoke transmitted to the ThinkSpeak cloud in the real-time scenario, because this particular data is being transmitted through the 4G SIMs, and that 4G SIM we integrated into the sensor modes, and they were transmitting this data to the main station, and from that main station, we were transmitting this data to the ThinkSpeak cloud. As far as the coordination between the modes is concerned, I have shared in the previous figure that we have implemented the the topologies. So in that particular case, the topologies which we have used was the cluster topology. So in this particular case, if these sensor modes were deployed like this way, these all modes were supposed to sense in their nearby areas and transmit the data to the cluster head. The cluster head are supposed to transmit it to the base station, and from the base station, we received it directly through the internet at ThinkSpeak, and from ThinkSpeak we can have the display of the data, we can take the appropriate decisions, and if there are some incident, we can report it to the concerned authorities through the SMS and through the email. And in the background, we keep on storing the data if something is, if the things are going normal. So this is how we try to identify the uses of this particular technologies in different scenario. As far as the detail of data sets which are available is concerned, the first and the most important data set which was available was the Flickr Fire data set, and it was developed in 2015, and the number of images which are available are 2000, and the image size is 1024 into 768, and in that particular case the frame rate was 1 frame per second, and the format of the images where this data set is being prepared was in PNG format. There was another data set which is also being used in different studies is Corsican Fire database, and in this particular case their number of images were 500, the size was similar, and the frame rate was 1 frame per second, and again the format of image was PNG. There was another large scale database that was available, and that is called as Landsat 8. This was developed in 2020, and there was around 31,000 images, and the image size was put quite larger, but the frame rate was same, and in that case also the format of image was TIFF. So in that particular case, we use a similar methodologies as I have shared with all of you. We try to collect the data, and then after collecting the data, it was commuted to the cluster head, and from the cluster head, it was sent back to the ThinkSpeak cloud. So this was the kind of the forest fire detection system which was proposed. So we try to place these nodes at different places. These nodes were locally transmitting it to the cluster head. From the cluster head, and it was passed on to the base station, and from base station it was sent back to the cloud. When it was available in the cloud, we have an access it globally, so there is no need to just have a restriction that you can have an access of the data through a particular storage unit, because once it is in cloud you can have an access at anywhere in the world. You just need an internet, and that data is available at the smartphones, or you say the tablets, and we can see the pattern, how the values are being changing, and based on the varying values of these particular the sensors data, we can identify where there is an incidence of fire or not. So that is basically about the hardware descriptions where the different sensor is being used, and that was the voltage requirement for each sensor, and this is basically the range of values which is shown. So these are the experimental scenario. We just took few figures just for showing these incidents. And in this particular case, if we look at the performance of a system, we found that the response time and the standard deviations achieve 7.56 millisecond of standard deviation and 24.56 millisecond of response time. So, in order to further improve the localization and localization of sensor node and improving the accuracy rate, we just try to put few additional efforts. In that case, we use the anchor node method and range free method, and in this particular case we applied and try to compare the performance of DRLS and GSL algorithms on one hop, two hop, and the head anchor count. So this is about the algorithmic process which is available in the published paper. So if I would say, when we use these particular two techniques, which is DRLS and grid scan, along with the bit modifications in our proposed system, these are basically the percentage accuracy which have been achieved. So the proposed systems was able to estimate the position of a normal node by the minimal connectivity, and the normal node collect the information of one hop, two hop anchors in a better way. So the proposed algorithm achieve better location estimation accuracy than the existing grid scans. And in the rest part of the work, what we try to do is, uh, in the extended part, we use the UAVs also to verify the incidents. And when the UAVs are being used to verify the incidents, and we can handle the scenarios where we identify the, you say, where the system has place the alarm in case of the wrong scenario. So here the whole idea was, uh, with the help of the UAVs or the drones, we can just identify the location where the incident of fire is reported, and we can take the live pictures, and we can verify the scenarios, and accordingly we can take the necessary actions. So these are the few three data sets where few the images I have taken just to show you what kind of images are provided. These the details of three data sets I have already discussed with you, and on this we applied with modifications, and we come up with a better accuracy as compared to the available techniques which were available. So this is how I just try to